the cranial nerves. Looked at the nerves, the peripheral nervous system in general. There are 12 pairs of cranial nerves that are associated with the brain. Two of them attached to the forebrain. The rest are all from the brain stem. Most of them are mixed nerves, but there are a couple that are just sensory. They are numbered 1 through 12, but they also have names. They're named from rostral to caudal, so from front to back. And there are a number of different word acronyms that you can use to remember those names once you learn them. A couple here would include: on occasion, our trusty truck acts funny, very good vehicle anyhow. Or, oh, once one takes the anatomy final, very good vacations are heavenly. Those would each have the first letter of one of the 12 cranial nerves. And I am sure if you go online and search, you will find other mnemonic devices which may not be appropriate for mixed company that will help you as well. Well, they are, though, however, the olfactory nerve, the optic nerve, the oculomotor nerve, the trochlea, the trigeminal, the abducens, the facial, the vestibular ocular, the glossopharyngeal, the vagus, the accessory, and the hypoglossal nerve. And you can go through these diagrams on your own. 13.6, we're going to talk about each one of these nerves individually. So the olfactory nerve is a sensory nerve of smell. It runs from the nasal mucosa to the olfactory bulbs, passing through the cribriform plate of the ethmoid bone. Its fibers are going to synapse in the olfactory bulb, and it's going to terminate in the primary olfactory cortex. It is just sensory. It is only olfactory smell function. Optic nerve comes from the retinas, which is really just a brain tract. Your eyes literally are an outgrowth of your brain. They passes through the optic canals where they converge and partially cross over at something called the optic chiasma. The optic tracts continue to the thalamus where they synapse. The optic radiation fibers are going to run to the visual cortex in the occipital region. And it is also purely sensory. It'll only visual information. The oculomotor nerves extend from the ventral midbrain through the superior orbital fissure to the 4 of the 6 extrinsic eye muscles that we'll look at when we look at special senses. They function in raising the eyelid, directing the eyeball, constricting the iris, and that is part of the autonomic nervous system, the parasympathetic part, and controlling the shape of the lens. The trochlea nerve, number 4, its fibers are from the dorsal midbrain, entering the orbits through the superior orbital fissure, innervating the superior oblique muscle. It is primarily a motor nerve that directs the eyeball. Number 5, the trigeminal, is the largest of the cranial nerves. Its fibers extend from the pons to the face, which divides into 3 divisions: the ophthalmic, the maxillary, and the mandibular. The ophthalmic passes through the superior orbital fissure, the maxillary through the foramen rotundum, and the mandibular through the foramen ovale. It's going to convey sensory impulses from various areas of the face, that would be V1 and V2, and it's going to supply motor fibers for chewing, that's V3, mastication. Number 6 is the abducens. Its fibers go from the inferior pons, entering the orbits through the superior orbital fissures. It is primarily a motor nerve, innervating the lateral rectus muscles. Number 7 is the facial nerves. Here, fibers from the pons travel through the internal acoustic meatus and emerge through the stylomastoid foramina to the lateral aspect of the face, the side of the face. It's chiefly a motor nerve with a face of 5 major branches. Its motor functions include facial expression, parasympathetic impulses to the lacrimal and salivary glands. Although it does have sensory function, there are taste receptors which work through here that come from the anterior 2/3 of the tongue. And this little diagram down here is very good at the course of those 5 branches of the facial nerve. Number 8 is the vestibulo-ocular nerve. It's got afferent fibers from hearing receptors. The cochlear division carries those. Equilibrium receptors for the vestibular division. They're going to pass through the inner ear through the internal acoustic meatuses and enter the brainstem at the pons medulla border. These are mostly sensory function. There is a small motor component that helps to adjust the sensitivity of the receptors. This one used to be called the auditory nerve. You may see that in some older texts. Number 9 is the glossopharyngeal nerve. These fibers from the medulla leave the skull through the jugular foramen and run to the throat. Its motor functions innervate part of the tongue, the pharynx, for swallowing, also provides parasympathetic fibers to the parotid salivary glands. Sensory functions include fibers that conduct taste and general sensory impulses from the pharynx and the posterior part of the tongue, as well as impulses from the carotid chemoreceptors and baroreceptors. Baroreceptors detect changes in blood pressure. The vagus nerve. Vagus nerve is like the xiphoid, not the xiphoid process. The vagus nerve is like the hyoid bone. It's always a question in an anatomical trivia. It is the only cranial nerve that goes beyond the head and neck region. Its fibers from the medulla exit the skull via the jugular foramen. Mostly motor fibers that are parasympathetic and regulate activities of the heart, the lungs, and the abdominal viscera. It does have sensory fibers that carry impulses from the thoracic and abdominal viscera, as well as baroreceptors, again, pressure, chemoreceptors, chemicals, and taste buds for the posterior tongue and pharynx. "11 is the accessory nerves. They're formed from the ventral rootlets from C1 to C5 of the spinal cord, not the brain, so this one is not directly off the brain. But its rootlets pass into the cranium through each of the foramen magnum, and the accessory nerves exit the skull through the jugular foramina and innervate the trapezius and sternocleidomastoid muscles. This one used to be called the spinal accessory nerve. The hypoglossal nerve, number 12, is fibers from the medulla exiting the skull through the hypoglossal canal. It's going to innervate extrinsic and intrinsic muscles of the tongue that contribute to swallowing and speech. And here they are again. Again, I won't walk you through all these figures, but they are very good, very useful. Some of your answers for your homework may be found only in the figures. The olfactory and optic nerves, the neuron cell bodies, are located within the special organs themselves. We'll see those when we talk about the special senses. For the other nerves with sensory information, the neuron cell bodies are located in the cranial sensory ganglia. Some mixed nerves have both somatic and autonomic fibers. The motor neuron cell bodies are in the ventral gray matter of the brainstem, while some of the autonomic motor neurons are within ganglia. In addition to remembering the names of the cranial nerves, you can use some mnemonic devices to remember whether they are sensory, motor, or both. So some say marry money, but my brother believes it's bad business to marry money. So if we take the first letter, you get sensory, motor, or both, and the order from 1 to 12. All right, and that covers the cranial nerves.